Good afternoon, class. Here's chapter 3, derivatives, section 3.5, the chain rule. The second part is implicit differentiation. Implicit differentiation, and we've done a portion of it. We're going to continue with some examples. Example 1, a small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So we're dealing with word problems, application problems. We need to understand what's given. First and foremost, we need the piece of information from geometry, algebra, you name it. Here's a circle. From the center to the circle, this distance is radius. 2 times that is the diameter. If you want to find the area of a circle, you use the formula A equals pi r squared. If you go around it, you find the circumference, C equals 2 pi r. So we should know all of these formulas. The one we need is the first one. Now let's read it one more time and write the given. So circular ripples spread over the surface with the radius of each circle increasing at the rate of 3/2 feet per second. The moment you see rate, that refers to differentiation. So dr dt is 3/2 feet per second. Find the rate at which the area is changing. The dt is missing. At what point? At the precise moment when r is 4, and of course we are using a equals pi r squared. So this is the translation of this question. We need to differentiate this with respect to t. Remember, t is the independent variable. Every other variable is a dependent variable. So if I want to take the derivative with respect to t, I'm going to write dA dt equals a pi, because pi is a coefficient, it's a multiplier, times r squared, and I'm going to differentiate r squared, and that is 2r dr dt because of the chain rule in Leibniz's notation. So 2 pi r dr dt, I'm going to replace the r with 4 and dr dt with 3/2. We get 12 pi square feet per second. A couple of things I want to mention here. The units are units of the numerator over the units of denominator, or you can work it out here. If you replace the r with 4 feet rather than 4, and the r dt with 3/2 feet per second, you get the same units. This is an exact answer. This is an approximation. You must always write the exact answer. And if they ask you to approximate, you do so. Again, reminding you that all of this can be found under the modules. In Canvas, you're just writing the solution. Find dy dt for equation 4x plus 3y to the power 4 equals x squared, where dx dt equals 10, x equals 4, y equals minus 2. What you should notice, the moment you see dy dt, that means t is the independent variable. And look, you have dx dt, which means, this is important to understand, the derivative of y is dy dt, the derivative of x is dx dt, not 1. Why? Because x is not the independent variable, t is. Therefore, 4x gives you 4 dx dt. 3y to the power of 4, this gives you 12y cubed times dy dt. In essence, you're using the extended power rule. x squared, 2x dx dt. Now we are done with calculus. Done with calculus. There are two ways to handle it. Just plug in or solve for dy dt and plug in. I'm going to show you both ways. You can just plug in the information that you have here. So 4 times dx dt is replaced with 10, 12, y negative 2 cubed, dy dt is missing, 2 times x, which is 4, dx dt, which is 10. Just plug in. This is negative 8. 4 times 10, 40. 12 times negative 8 minus 96 dy dt. 2 times 4 times 10 is 80. Move the 40. The right side is 40. Divide by negative 96. Simplify the fraction into minus 5 over 12 because they are both divisible by 8. Or, and you're done, and that's fine. Or over here, we want to solve for dy dt, so we have to move 4 dx dt to the right. We're going to divide both sides by 12y cubed. First, we take the factor of 2 dx dt on the right side. So dy dt becomes dx dt times x minus 2 over 6y cubed. Now, if you plug in, you get exactly the same answer. One step of calculus. Find the x dt for the equation 3x plus y e to the power of x equals 20, where dy dt is negative 8, x is 0, y is negative 1. Again, your independent variable is t. Therefore, 3x gives you 3 dx dt. What about y times e to the power of x? Let me put a raised dot in between. So it's y times e to the power of x. So you're using the product rule. F times G is F prime G plus G prime F. So F, let me just write at top of it so be clear as to what's going on. So if you call this one F, this one G, you need F prime, which is dy dt times G, which is e to the power of x, plus G prime F, the derivative of e to the power of x is itself, times dx dt, because t is the independent variable. So e to the power of x dx dt times F by the product rule, where f is y. The right side is a number. Any number results in 0. So we could write this as follows. So this is f prime g plus g prime f using the product. Now, believe it or not, we are done with calculus. So we plug in those values. Meaning dy dt is replaced with negative 8, x is replaced with 0, dx dt is missing, and y is negative 1. Anything to the power of 0 is 1, so this is 1. And so we have 3 dx dt minus 8 minus dx dt on the left side. These two add up to 2 dx dt. Negative 8 goes to the other side, positive 8 divided by 2, and we get 4. Dx dt equals 8 over 2 or 4. Now, we are done, and that's fine. But just to make sure we are comfortable with this, I'm going to look at the second method. meaning I'm solving for dx dt anything. This is the calculus step class. This is the only calculus step. So in this case, I'm going to keep anything involving dx dt on the left side, and I'm going to move dy dt times e to the power of x to the right, make it negative. On the left side, I factor the dx dt out. It gives me 3 plus y e to the power of x. I have to divide both sides by this parentheses, 3 plus y e to the power of x, in which case the left side becomes dx dt and the right side divided by 3 plus y e to the power of x. If we plug in, it will give us the same answer. Again, you can go either way, but you need to understand the concept of a differentiation. This is the important step, which is differentiating. Find dy dt for the equation 5x plus y to the power of 4 minus x equals 6, where dx dt is 3, x equals 2, y equals negative 9. Again, the fact that you have dy dt, you have dx dt is telling you t is the independent variable. So if I want to differentiate that, I'm going to stick with the extended power rule. I put the 4 in front. Then I put the same thing to the power of 3. That's n g of x to the power of n minus 1. And then by the chain rule, I need g prime of x. I need the derivative of the inside. I need the derivative of the parentheses, which makes it 5 dx dt plus dy dt. So the derivative of the inside is what you see here. Minus x, that means minus dx dt, any number, including 6, results in 0. And again, we are done with calculus. This is the only calculus step, everybody. Plug in, which means replace the x with 2, y with negative 9, dx dt with 3, dy dt is missing. We are solving for minus dx dt is 3. So everything that you see from here on is elementary algebra, basic math. 5 times 2, 10 minus 9 is 1. 1 cubed is 1. This whole thing is 1. And 4 times 15 is 60 plus 4 dy dt minus 3. And the two numbers add up to 57. On the left, we move it to the right, make it minus 57. We divide both sides by 4. And it results in dy dt equals minus 57 over 4. Now, I'm not going to go with the second method of solving for dy dt. If you want to do that, you can move this to the other side, divide by this, and then move this one to the other side, find dy dt. There are different ways of approaching it. I leave it for you to do so. But this is just as good. Falling sand is forming a cone-shaped pile. The volume of the cone is increasing at a rate of 54 pi cubic inches per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. So you're dealing with a word problem. You have to read and reread until you get everything that is given. First and foremost, we are dealing with a cone. Here's the shape. Here's the radius of the base. Here's the height. And the volume is 1/3 pi r squared h. So this we should know from algebra/geometry. So let's go back and reread. The volume of a cone is increasing at a rate rate of 54 pi cubic inches per minute. So dV dt is 54 pi cubic inches per minute. By the way, pi is being multiplied by 54 is part of that because it makes it an exact answer. The height, h, is twice the radius. H is 2r. H is 2r. Okay. Find the rate at which the radius changes. The rate at which the radius changes. dr dt is missing when r is 6. So this is the translation. We need the formula for the volume. dV dt is 54 pi cubic inches per minute. The relationship between h and r is that h is 2r. dr dt is missing when r is 6 inches. Now, we need to find the v dt, which means we're going to differentiate this with respect to time. However, before we do that, we notice there are two variables, r and h. Since we want the r dt, we are going to replace the h with 2r. The question was asking for dh dt. We would replace the r, and r is h over 2. So let's replace the h with 2r. The product gives us 2/3 pi r cubed. First, this is basic math. And now this is a function of r, and we can differentiate it with respect to r and then with respect to time because it's a function of time, related rates. So dy dt is dy du dt. So we're going to have dv dt, which is dv dr dt. So first, to differentiate this, you keep the 2/3 pi because it's a multiplier, and you just deal with r cubed. What is the derivative of r cubed? 3r squared. And this part results in dr dt. So one more time, r cubed, 3r squared, dr dt. Because r is not the independent variable. T is. This 3 cancels out this 3. We get 2 pi r squared, dr dt. And now we are going to plug in. This is it. One step of calculus. Everything else, understanding the question, plugging in, remembering some basic formulas from geometry, and now dv dt is, see, when you write the given, it makes life easier. Replace it with 54 pi. The right side 2 pi times 6 squared dr dt is the one that we are going to find. This is 36 times 2 pi makes it 72 pi. We're going to divide both sides by 72 pi. The pi cancels out the pi's. 54 and 72 are both divisible by 18, 3/4 of an inch per minute as far as the units are concerned. The units of r over the units of time, inches per minute. So the answer is 3/4 of an inch per minute. So again, in short, it's important to read and reread, be able to come up with the given symbolically, everybody. A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. So we need to understand the question. So here's the wall or the building, here's the ladder. It's moving this way. Okay, so as you can see, the shape created is a right triangle. As it moves this way, as it slips away, it gives rise to this coming down. So this goes to the right, this comes down. So we have this ladder fixed at 20 feet. Going this way, dx dt is 2 feet per minute. Coming down, we have dy dt missing. So this is understanding the setup. So you have to go with the setting. So dx dt is 2 feet per minute. Dy dt is missing. We want to find it at the moment. The base is 12 feet. What is the base? X. Now, what else should we add? We know, according to Pythagorean theorem, a squared plus b squared equals c squared. A and b are two legs of the right triangle. C is the hypotenuse. So x squared plus y squared is 20 squared. So this translates to x squared plus y squared is 20 squared. Of course, 20 squared, everybody knows it's 400, but I just wanted to write down 20 squared to begin with. We have to differentiate this in order to get to dy dt because dx dt is given. X squared, 2x dx dt. Y squared, 2y dy dt. Any number, including 400, 0. This is the only calculus step. Now, we are interested in finding dy dt. We have the x, which is 12 feet. We have dx dt, which is 2 feet per minute. But we don't have y. How do we find y? When x is 12, if I plug in, at the moment x is 12, I can find y. And I leave it for you to verify that y is 16 feet if you plug in. So when x is 12, y is calculated as 16. Now I have everything except dy dt. I'm going to plug in. So 2 times x, which is 12, dx dt, which is 2, plus 2 times y, which is 16, dy dt is missing, equals 0. This is 48. This is 32. We are going to write 32. Dy dt is negative 48. Divide both sides by 32. They are both divisible by 16. Negative 3/2 feet per minute. I'd like you to notice that as we move this way, x is increasing, therefore dx dt must be positive, and it is. As it comes down, y is decreasing, therefore dy dt must be negative, and it is. Now, as things move, there is an angle here and there's an angle here. Those are changing as well. Now we're going to look at the next question, which in essence is part B of this question. A 20-foot ladder leans against a building. The base of the ladder slips away at the rate of 2 feet per minute, identical to the previous one. Now, what is it that we want to find? Find the rate of change of the angle between the ladder and the ground when the base is 12 feet from the building. Identical to the previous question. This is part B in essence. So this is the wall or the building. This is the ladder. It slips away this way and it creates this shape, which is a right triangle. As it moves this way, y comes down. And this is the angle of interest. There are two angles. This is the one we want. Okay, the angle between the ladder and what? The ground. So now what we are interested in, if This is 2 feet per minute. That means dx dt. What is d theta dt? We are interested in calculating d theta dt. So first I'm going to write exactly what we had from the previous page. The only thing I'm adding, we are interested in d theta dt. In other words, dx dt 2 feet per minute. X squared plus y squared equals 20 squared. This can help us find something in the in this example, although we already have it from the previous page. D theta dt is of interest to us when x is 12 feet. So anytime you want to find something, you want to, in a related rates problem, you have to find the relation between the two. So in this case, d theta dt is missing where dx dt is given. So you want to find a relationship between x and theta. So notice from basic trigonometry, sine theta is the opposite, which is y over the hypotenuse, which is fixed at 20. Cosine theta is the adjacent, which is x, over the hypotenuse, which is fixed at 20. So I'm going to write this one first because this gives me a relationship between theta and x. And of course, I write this one as y over 20. You could use this because we've already calculated dy dt, so we have it. However, always use the given because what if we made a mistake with our calculation here? We're going to use this. And what I'm going to do, first, I'm going to change this to the format so it is clear that 1 over 20 is just a number, is a coefficient. Then I put a underline cosine so everybody can see we are differentiating cosine, which gives you the answer negative sine. But it's important to know theta is not the independent variable, otherwise we would be done. But t is the independent variable. That's why we want d theta dt. So times d theta dt. And the right side is 1 over 20 times x results in dx dt. Now, what is sine? I can replace the sine with y over 20, but what is y? From the previous page, we calculated the y to be 16. So minus sine theta y, or 16 over 20. The right side is 1 over 20 times dx dt, which is 2. To solve this, you have a fraction here, you have a fraction here. You can get rid of the 20, or you can say you're going to multiply those sides by 20. Either way makes no difference. So what you are looking now is minus 16 d theta dt equals 2. If you divide both sides, by negative 16, d theta dt becomes negative 1 over 8 radian per minute. As far as the units are concerned, the units of the numerator over the units of the time. The units of the numerator is the units of angle. And in calculus, it's always in radians, unless otherwise mentioned. It is always in radians. So minus 1 over 8 radians per minute. Notice, as it slips away, x is increasing. Of course, the x dt is increasing. But theta, what happens to theta? Theta is getting smaller, is decreasing, and therefore d theta dt must be negative, and it is. Example 8, a spherical balloon is deflating, losing 8 cubic centimeters of air per minute at the moment when the radius of the balloon is 20 centimeters. How fast is the radius decreasing? We should know this already. We've discussed that in the previous session. The volume is 4/3 pi r cubed for a spherical shape. So using that, and now let's reread. It's deflating or losing 8 cubic centimeters of air per minute. That will tell you that it's dV dt. dV dt is negative 8 cubic centimeters per minute. And at the moment when the radius is 20 centimeters, when r is 20, what is dr dt? So the volume, as the formula for thirds power cubed, given dv dt is minus 8 cubic centimeters per minute. Dr dt is missing when r is 20 centimeters. Now all we have to do, differentiate this. I hope you remember we've done that already. So 4/3 pi is just a number and remains. R cubed 3r squared dr dt. So it's 4 pi r squared dr dt, and all we have to do, replace the dv dt with negative 8, or with 20, this is 400. So 400 times 4 pi is 1600 pi. We are going to divide both sides by 1600 pi. 8 goes away, 16 changes to 2. The answer is dr dt is negative 1 over 200 pi centimeters per minute, units of radius over the units of time. This is then an exact answer, everybody. You put it into a calculator, and a rough estimate of negative 0.001592 centimeters per minute. This is an approximation, and with however many decimals they ask you to come up with. And that's it.